Hi everyone and welcome to the Learning Curve. On the Learning Curve, you learn all things math. Today we're going to be focusing on the solution of this problem. Determine the distance between each pair of points and round our answers to the nearest tenth. So we're given these 2 points on this graph. This is point number 1 right here, which I'm going to call this point A. So let's just label that point A for simplicity. And the coordinate of this point A is 3, 4. Here, 3 on the x-axis to 4 on the y-axis. We also have this point, second point, which we're going to call B. And the coordinate of this point is 6 on the x-axis to 8 on the y-axis. So this is B and this is A. What we're asked to do here is to find the distance between these 2 points A and B. And there are 2 ways, well, a number of ways, but 2 popular ways in which we can do this. One of which is to find this distance between A and B using the Pythagoras Theorem. Another popular way is to use the distance formula, which was developed by mathematician Descartes. In this video, my focus is going to be on using the Pythagoras Theorem to find the distance between points A and B. So our first step in using the Pythagoras Theorem to find the distance between A and B is to form a line segment, which is simply a line connecting A and B. Straight line connecting A and B. So now we have a line segment that connects A and B. Since the Pythagoras Theorem applies specifically to right triangles, our next step is to construct a right triangle from this line segment. There are 2 ways to do this. One way is to go down from point B and then across to point A. And here we would have formed a right triangle. Another way would have been to go across from B here and then down to A. Either way is fine. The critical thing here is to form our right triangle, which we have. Now that we have formed our right triangle, we're going to label the lengths that are formed in this triangle. The line segment AB, which is the longest length in this right triangle, represents the hypotenuse, which we're going to label that hypotenuse as C. And we're going to label the base area of the triangle, that's the bottom area of this right triangle, as B. And we're going to label the height of this right triangle as A. We always have to label the longest length in the right triangle as C. Technically, it does not matter which of the other 2 lengths you call A or B, but for simplicity, you can call the bottom length B. So we have a nice right triangle here where we have labeled the hypotenuse, the longest length in the right triangle, as C, and we've also labeled the base B and the height A. Now we can easily determine the values of A and B by simply determining the distance between the points that are related to these labels. So, to make this very simple, I'm going to label this additional vertex that is formed as C. So this point here connecting at the right triangle. The edges of the triangle are what we call vertices. So an individual edge, like this edge here at C, is called a vertex. There's also a vertex at B and a vertex at A. So for simplicity, we label this additional vertex that was formed as a result of creating this right triangle as C. So what we're going to do now is that we're going to determine the distance between point A here and point C here in order to determine the length of that line AC, which is the same as the length represented by B. To do this, we must recognize that the x value here at point A is 3, and recognize as well that the x value at point C is 6. So here we simply need to determine how many values are there between A and C, and that would give us the value of the length B. So doing this is very simple. Since each square here represents 1 unit, we're going to realize that 3 to 4 is 1. Here, 3 to 4 is 1 unit. Then 4 to 5 is going to be another unit, that's 2. Then 5 to 6 is another unit, which is 3. So the value of B is 3 units. And our next step is to determine the value of A. To determine the value of A, we're going to use a similar process. However, since A is the height, which is a vertical line, instead of using the x-axis this time, we're going to use the values on the y-axis to determine how many units are covered by the distance between C and B here, and that will give us the value of A. So since C corresponds to a y value of 4, and B corresponds to a y value of 8, we recognize that we could easily find the length of A, which is the distance from point C to point B vertically, by simply taking 8 here minus 4, which is 4. Or we can simply count the number of squares between C and B here, because each square represents 1 unit. So it's be 1, 2, 3, 4. That's 4 units between C and B. So the vertical distance A, which is the height of this right triangle, is 4 units. So now that we have determined A and B, we can now easily find the value of C, which is the hypotenuse, the longest length in the right triangle. Now we cannot use the same method of counting squares to determine the value of C, or to estimate it using the distance between numbers or the difference between associated numbers on the axis. We can't use the same approach that we took to find A and B. We can't use that same approach to also find C. To find C, we're going to remind ourselves of what the Pythagoras Theorem says. According to the Pythagoras Theorem, the square of the hypotenuse, which is C squared, is equal to the square of the two adjacent sides. So that would be A squared plus B squared. In other words, we can calculate the value of C using this Pythagoras theorem, which says the length of this hypotenuse, the longest length in this right triangle squared, is equal to the square of the height A plus the square of the base B. When we transpose for the value of C from this, we realize therefore that C must be equal to the square root of A plus B, and we're squaring both of these. So C is equal to the square root of A squared plus B squared. By transposing for C, this is always what C is going to be equal to, because we're not interested in finding C squared, we're interested in finding C itself. In order to get rid of the power of 2 that exists for C here in the Pythagoras theorem, we do that by taking the square root of C squared, which gives us C. And what you do to one side of an equation, you have to also do to the other side. So we take the root of A squared plus B squared as well. So therefore, this is how we arrive at this very important fact, which is that in a right triangle, the hypotenuse C here is equal to the square root of a squared plus b squared. Therefore, let's go ahead and calculate C. So since we know from our earlier computation that C is equal to 4 units, so we're going to have 4 squared, and B is equal to 3 units. We're also going to have plus 3 squared, and of course we're taking the square root of this. So this becomes C is equal to the square root of, we know that a number squared means that number multiplied by itself. So 4 squared here means 4 multiplied by 4, which is 16. And 3 squared here means 3 multiplied by 3, which is 9. So that's how we do it. And we then, our next step is to simplify the expression under the square root, which is 16 plus 9, and 16 plus 9, of course, gives us 25. So we end up with C equal to the square root of 25, which is 5 units. And so now we've found the distances of all 3 lengths, A, B, and C, and we have satisfied what the question asked us for specifically, which is to determine the distance between each pair of points. So our answer is 5 units. So if we notice here, A is equal to 4 units, B is equal to 3 units, and C is equal to 5 units. And our result here represents one of the famous, very famous, what are called Pythagorean triple. So the Pythagorean triple here is 3, 4, 5. This is a very famous Pythagorean triple, which represents the ratio between the values here of A, B, and C. And that's the solution for this problem. Much more to learn on the learning curve. Thank you for joining. See you soon.